I'm about to show you how to fix a Sony TV with a dead no power fault, and the customer sent in their power supply for us to diagnose and repair if it is defective. For those of you who don't know me, my name's Nick. I started Nick's TV Repair more than a decade ago, and since then have fixed over 27,000 devices. Let's start with our diagnostics. It might be a bit counterintuitive, but most often with Sony TVs, a dead no power fault is typically going to be caused by the main board, not the power supply. So my first step is I want to make sure that the power supply is sending proper power to the main board. We're going to go ahead and plug it in. And using my multimeter in DC mode, I'm going to put my negative lead on the chassis ground and take a quick look for the standby 3.3 volts, which is pin number 5. And when taking my measurement, I'm actually not getting any power at all to the standby voltage. That does confirm my power supply is defective. I've placed my multimeter in continuity mode, so I'll get a beep when we have a short. We're going to flip the board over. I'm going to place one of my leads on pin number 5, which is our standby pin, and we're going to trace it out. I want to identify where is this standby coming from. So it goes here, then it jumps through this fuse, and it looks like it splits into two paths. One over here and one over here. So let's take the larger one for now. Follow that. It's going to come down here, over here, keeps coming down, up over here. We have a capacitor, and then over here, resistor. Okay, let's see here. So I think we just found it. I'm going to put one of my leads on pin number 5 again to confirm, and it does look like this transformer here goes directly to the standby voltage. Both sides are shorted to one another, and I think for the transformer that's normal. I placed my lead on the diode, which means that the transformer and the diode are connected, but I also put my lead on the other side of the diode and still got a beep, which that's not normal. Both sides of the diode are not supposed to be shorted to one another, and it looks like that's the case. So let's remove that diode and see what we get. The location ID of the diode is D950A. Okay, actually it's looking like this might be a little bit more difficult because of the way the joint is set up. So I'm gonna add a little bit of fresh solder again. And the way we're gonna remove it is not by desoldering it, but just pulling it through. So I'm gonna use my needle nose pliers. I'm gonna grab it on one side. And what we'll do is I'll melt the solder, get good flow, and I'm just gonna pull the leg through with the pliers. All right, and we'll do the same to the other side. And there we go. All right, now let's go ahead and clear the holes. There we go. There we go. We're still in continuity mode, so we should no longer get a beep. And we don't. Let's check the diode. And the diode was the short. All right, I do already have my replacement diode ready to go. We'll go ahead and feed it through the holes. Push it through. Now we can go ahead and solder it down. Cut off the leads. And let's do one last check. No more short. Let's do a resistance measurement to see what we're expecting. And now in the normal resistance, we are getting about 8 mega ohms, 7 mega ohms. Let's swap our leads. And with our leads in the opposite direction, we're getting 0.7, 0.8 kilo ohms and rising. Okay, so our short is definitely gone. Let's power it up and confirm that our standby is back up. So we are back in DC mode. We're still gonna use our chassis as ground. Let's go to pin number 5 down here. And look at that, we are now getting our voltage. That's our standby. Let's measure the filter cap next. And we're only getting 169. So we're actually supposed to be getting about 380 to 400 when the power supply is fully activated. So this means actually the power supply is not yet fully activated. What we're gonna do here is I'm gonna use this special connector I built. What it's gonna do is it's going to short together the standby voltage with the power on command, and that will fully activate the power supply. And I just heard it click. Now if we take another measurement once more, okay, and we are now getting a 390 volts. That's better. And this is not necessary, but let's go ahead and do a measurement of our output voltage for the LEDs. And we're getting 68 volts, and 68 volts, and 68 volts, and 68 volts. Okay, so all of our output voltage for the LEDs are correct. Let's do one last check. I wanna make sure my regular 12 volts and my T-Con 12 volt is present. According to the legend, my 12 volt is pins 13 through 18. So let's go ahead and do that measurement. And of course, we are getting 12 volts. Let's check the T-Con 12 volts next, which is 25, 27, 28. That's going to be our last ones down here, and 12.8 volts. So that confirms it. We have another successful power supply repair. The customer was indeed correct. The power supply was the cause of the fault. Now again, the main board is the most likely culprit for a dead no power. So if you do encounter that issue, just double check the standby voltage and make sure it's present. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.